Okay, we're back at the functional table. We did, I think it was 5 plus 3, that's an 8. We did 9 plus 7, that should have been what? Yeah, you can guess that. So fill out the rest of this and also make sure that these are correct. If they're wrong, then you want to change those and then go through the, uh, the test table. Okay. If you have a DVM, you can make a measurement on one of these or another. If you don't, you can approximate that or maybe do some Ohm's law. Okay. Okay, we're gonna go on. This is, oops, this is our other, this is another, you can put in whatever you want and see what those values are for whatever value you put in, okay? These are some of the critical questions you want to answer. This will be compliant to our rubric as well as our ABIT engineering outcomes. Okay, I think you could probably much handle these. This is an interesting one. How would you cascade two 7483 ICs to create an 8-bit adder, which we're going to do about 3 or 4 laps down the road, which we'll also use, we'll be using 1 complements and 2s. Now in chapter 2, we mentioned that, but again, we're going to get back to that. If that kind of got you a little bit going, wow, we're going to do this kind of stuff, it's not that bad, so it'll be okay. We'll have a discussion post on that too, so it's just do your best. I mean, this is kind of new stuff to you, but it'll come, okay? These are other scenarios you want to test and confirm, or write your own analysis of this. This is what we're really looking for. I think the most important thing is to kind of describe if you did get an error, you didn't, or you got this right or wrong. The the communication that you write about in terms of your critical thinking is really regarded, as very essential in engineering. Okay, so it's not always getting the right answer or being perfect. It's also trying to understand, some of the challenges you had, or maybe you didn't have any. Okay, so these are some of the guidelines here. Again, these are our A-bit. We're using 1 and 3 and 5 and 6. Now again, data sheet, we're throwing you right into reading data sheets, and I think that's good. Maybe you did that in DC or AC, and that's a good start. You'll be doing this throughout your career as a technician or maybe an entry-level engineering technician as well. If you go to more school, you'll definitely always look at the data sheets, okay? Now again, we described that these are two different, functionally, logically, they do the same, but the pinouts are different. So we always leave it as an exercise for you to see which one you have. So if you're doing open labs, it could be this one. I'm not sure if they have this one, but you'll be using this one in the multisim. You can also build this in Tinkercad, and I'll upload a video for that by another guy. That's pretty cool to do as well. I know some students had problems getting Tinkercad, but I think if you create an account and then use my my login code, you'll be able to get in. One student did get in, and he posted something, so that was pretty cool to help out other students. NMOS and CMOS. So we learned a little bit about these logic levels, and we'll get more into that. This is an interesting noise margin. We'll also be getting a little bit more into that in terms of the different noise margins that are allowed in these circuits. Okay, so especially in transition. Here is a copy of the one that we were playing around with in Multisim. And that's it. I think you're going to find this lab pretty pretty fun. There might be some challenges, but I know that you'll overcome those. And if you're having a bad time or a hard time, just email me. We'll get this going for you, okay? Thank you for your time.